Hey, chilling in his nerd class, you know what's up. No compass to
Are you
make
guys
circles.
ready?
I'm using a cup, because I ain't finding no
Okay. Go ahead. Barely. Oop, yep, good thing. So, here we go, you guys. Today, like I just told you, we are doing my favorite topic ever. Ever. More factoring, that's right. So, what is so exciting about that? I'll say that the first piece of what we're doing today is not necessarily my favorite thing ever, but the second part is. So, here we go. We are doing two types of factoring today. Okay, back to group. Remember, trial today. We can switch seats in the middle of class if we need to. Okay, sum and difference of cubes. A cube. Anybody know what a cube is? Rebecca. Close. It's not quite to the power of 4. Deanna? Power of 3. All right, everybody give it up for Deanna. All right, so sum and difference of cubes. What does sum mean? Shout it out. What does sum mean?
Addition.
Add. Okay, so that's the first one, is if we have two perfect cubes. A and B represent the cubic root of perfect cubes. Okay, so if we are given two terms that are being added together, both of which are perfect cubes, it factors in this way. A plus B times A squared minus AB plus B squared. Okay, so let me write that up there. And, yep, that's one of them. The other one is the difference of cubes. A cubed minus B cubed. And this one factors into A minus B times A squared plus AB plus B squared. So, here is the big key with these. Yes, memorize these formulas, because as long as you have them memorized, then there is really no way that you can do these incorrectly. Crystal is not jealous of you all right now. Okay, so how does this look? Let's first go through, let's do something like this. X cubed plus 8. We want to factor this. So factor, remember we said yesterday that factor is a fancy word for dividing into parts. So we want to divide this into parts. So what I want you all to think about is a cube is something that you multiply by itself 3 times. But let's start with the 8. Can anybody think of something you multiply by itself 3 times to get 8? Samantha? 2. All right, give it up for Samantha. Everybody give it up for Samantha. Yikes. Okay, now, how about x to the 3rd power? Can anybody think of something that you multiply by itself 3 times to get x to the 3rd power? Don't overcomplicate. Zach? X. All right, give it up for Zach. Okay, so as long as you have your formulas memorized, it is super easy from here. What you broke down each term to be, in other words, what you found the cubic root of, those become your A and your B. Okay? We have a plus here, so which formula between A cubed plus B cubed and A cubed minus B cubed do you think we're plugging A and B or X and 2 into? If it says plus, and one of these says plus and one says minus. Aiden? The first one. Excellent. Everybody give it up for Aiden. Yeah. All right. So basically, we have the left-hand side already given to us. We now want to find the right-hand side. We just figured out what A and B are, so we're literally taking X and 2 and replacing them in for A and B into this formula. So if I, again, take the X and replace the X here with A, or other way around, replace the A with X, and replace the B with 2, the first parentheses becomes X plus 2. What about the second parentheses? Can someone tell me what they think that one comes out to? Alyssa?
X squared minus X 2.
Good. Minus X times 2. X times 2 is what? 2X. Good. And then plus 2 squared, which is how much? Excellent. Everybody give it up for Alyssa. And that is it. You are done. But You have to memorize them. If you don't memorize them, it makes it really, really hard. In fact, I'll say last year, even though I said to memorize them, there, of course, were people who did not. And you guys are going to be quizzed very heavily on these.
Yeah, and you get overcomplicated and then you get it wrong and then you start crying.
Or
Did you
that.
do that?
That's not good.
Yeah,
But then once people memorized the formulas, they were like, wow, this is really easy.
it's really easy.
If you memorize the formulas, I can't stress that enough. What's up, Cole? If you start out with a plus, you use the plus. If you start with a minus, like let's just do really quickly, x cubed minus 8. X cubed minus 8. Now which one do you think that we're going to be using? Bottom one. The only difference between the one we just did and the bottom one is that there's a minus here, so we use the minus formula. Can someone tell me what they think it comes out to in factored form, since now it's minus instead of plus? Zach?
X minus 8.
Okay, what is the cubic root of 8?
2.
2. Excellent.
X minus 2, x squared
Uh-huh.
plus 2
Uh-huh.
plus 2
And what's 2 squared?
4.
Excellent. Everybody give it up for Zach. Okay. So again, same x cubed, 2 cubed. The only difference is that we have a minus instead of a plus, which means we use the second relationship instead of the first. Okay. Now, here's a really easy way to memorize these. I'm going to scoot this back up here. A really easy way to memorize these is by looking at the signs. For everything, I'm hoping you guys can see that the factored versions are exactly the same as far as there being a squared, b squared in these. The only difference is that the signs change. You guys see that? Okay, so for the plus, a cubed plus b cubed, it goes plus, minus, plus. With the minus, a cubed minus b cubed, it goes minus, plus, plus. Okay? Use that to try and help you. Does that make sense to everybody or not really?
That makes sense.
Okay. All right. Let me give you a list of numbers. Everybody write this down. Because you're going to get some relatively large numbers on your assignment. 1 to the third power is 1. 2 to the third power is 8. 3 to the third power, 3 times 3 times 3 is 27. 4 to the third power is 64. Everybody should be writing these down. This is going to come in very handy. 5 to the third power is 125. No. This one is, but not that one. 6 to the third is 216. And 7 to the third is 343. That you want to keep that list on hand. As you get more practice with these, those will start coming more naturally. But okay, questions on this? No? All right. Now let's move on to the best thing ever.
Example.
That is going to be in a minute. Yes. Okay. Diamond method. Okay. Okay. Diamond method is a method that we use for factoring trinomials. Can somebody refresh my memory what a trinomial is? Cole? It's got 3 terms. Everybody give it up for Cole. 4. Method used for factoring trinomials, and again, like Cole just said, trinomial, that's 3 terms. So, this is going to be easier to explain with an example. Instead of trying to give you a bunch of general terms, examples work best. Okay, so here we go. Factor. If we have something like x squared, I'm going to do this really ginormously to start out with so you guys can see what's happening. From this point on, I'm going to label everything in some serious detail. From after this, after our notes, if you don't want to label, you don't have to. But I want you to get in the habit right now, okay? So, the number that comes in front of the x squared, we're going to label that a. Okay? The number, as long as it's in descending order. You always want to make sure descending order. Can someone remind me what descending order means again? Alyssa? Highest to lowest. In terms, good. Everybody give it up for Alyssa. So, in terms of what we're looking at, we're talking about exponents here. So this one has an exponent of 2, this one has an exponent of 1, and this is nothing. Then we have B is the one in front of x, and C is the one that does not have any x's attached to it. The next step, draw a giant X on your paper. Woo, that's a really big one. Okay. So in the top of this ginormous X, we are going to put A and C multiplied together. So what's in front of the X squared? Is there anything there? No, that means there's an invisible what? 1. 1 times 20 is?
20x squared.
20. We don't want to put the x squared, but just the coefficients, okay? Then in the bottom, we're going to put b. What is the coefficient we have for b? A 9. Okay. Here's how we find what goes in the sides of the x's, of the x. We are looking for two numbers that multiply to 20 that add up to 9 at the same time. So I want you guys to think for a second. Think about if there are two numbers that exist. So everybody be looking at the 20 right now. Think of numbers that you can multiply together to get 20, okay? And we're looking for, of those numbers, which two add up to 9 at the same time. Desi. 4 and 5. Everybody give it up for Desi. So that's what goes in the sides. The last step is we are going to take this x squared. Going to take the x squared and we're going to evenly distribute that x squared to each of these terms. If there are two of them, how many go in each side if we're evenly distributing it? 1. So when x goes here and x goes here, we make small little fractions, and as long as you can't reduce any of those fractions, those are your two factors. So x plus 4, positive x, positive 4, positive x plus 4, and x plus 5, those are your two factors. Whoops, you can't see that. Now, why is everything positive again? Samantha? Oh, that's good. Okay, B is positive and so is C. Excellent. Okay, are there questions on this? Sloan?
Is that it?
That's it. You're done.
Where's the 4 and 5 come from?
Did we get putting these numbers in here? Okay, so then here and here we looked for two numbers that multiplied to 20 and added up to 9 at the same time. So 4 times 5 is 20, and 4 plus 5 is 9. So it fits in this little x thing. So you want to make sure you have really good knowledge of your times tables when we do this unit. Brandon. It's a trick that works. We are going to get into some where there's a number in front of x squared, and using this method will make things a lot easier and quicker. Yeah. Questions on this? Brandon. You just write x plus 4 and x plus 5. This is not part of the answer. This is getting us to the answer, which is x plus 4 times x plus 5. Liz! A times C, yes. And B on the bottom. Yep. Good. Other questions? Okay. Let's move on. Now we have a few examples, okay? Actually, do I have contestants who would like to come up and do these? Oh, okay. All right. What do we think this kind of problem is? C cubed plus 27. Thane.
That is the cubic factoring.
Good, excellent. Everybody give it up for Thane.
27 would equal 3 cubes.
Good. So he's saying this is a sum of cubes problem. So if we will have these memorized by Friday. I should probably put up here that there's a quiz Friday, so you all know.
Yeah, that's
Quiz Friday on this stuff. FYI, memorize these two formulas. It's going to be a verbal quiz, meaning Oh, that's right. I'm going to come up and have you guys each come up one by one and ask you to say these verbatim to me.
Oh, okay, cool.
Okay, so who can tell me, if I have my formulas here to reference, who can tell me what c cubed plus 27 factors to? Shuggy. It's all right. Uh-huh. Excellent. Yep. Excellent. Everybody give it up for Shuggy. Nicely done. Now, had she not had that formula either in front of her or memorized, that would have been very difficult. But it took her literally like 10 seconds to do it, because she had the formula, which you all will have memorized by Friday. What's up, Alyssa?
Where did you get the 3?
Ah, because the cubic root of 27 is 3. 3 times 3 is 9 times 3 is 27. So this becomes your A, is C, and this becomes your B, which is 3. So it's based on the numbers. We're going to do another one right here, but
Do you
always
always have to do the cubic?
have to do the cubic root, yes, when you're dealing with sum and difference of cubes. Other questions? Okay, remember I gave you a really nice list of perfect cubes? Can somebody tell me the cubic root of 343x to the third power? Alan. 7x. Give it up for Alan. Okay. Can somebody tell me the cubic root of 125? Samantha. 5. Give it up for Samantha. So the first one we have is A. The second one we have is B. And now I'm going to take this list and move it around so that we have our A cubed minus B cubed right here. Can somebody tell me, first of all, which formula do I use? Do I use A cubed plus B cubed or A cubed minus B cubed? Sloan.
Minus.
Why minus?
Because
It's a minus in the original. Everybody give Sloan a round of applause. Okay, so this one I'm actually going to fill in with our things and do the final step at the end. So can somebody tell me what this factors to? So I've got my formula up here. It's a minus, so I'm using the minus, like Sloan said. So can someone tell me the first parentheses? Let's start there. Liz? 7x minus 5. Everybody give it up for Liz. Okay. If I'm plugging in 7x for A, then it's 7x squared plus 7x times 5. Whoops, I am off my parentheses. Plus 5 squared, and then we want to go back and simplify. Does this make sense to everybody what I did?
Yeah.
Okay, so now I want to go back and simplify that so we don't have squareds left in the problem as far as the numbers go. So 7x minus 5. All right, what is 7x squared? 49x squared. 7x times 5 plus 35x, and then 5 squared is 25. All right, everybody give yourselves a round of applause for contributing on that.
Yay!
All right, how are we doing on questions?
We're doing pretty good.
Doing okay?
Yeah.
So, do we all see how important it is to memorize those two formulas? Cool. What's up, Sloan? Do you have a question? Everything is important.
Well, I think if we keep going over it, then I'll be able to figure it out.
Okay.
So far, it's only been A that had the variable.
Uh-huh.
X. Will that ever be B the variable?
Yeah. So sometimes B can have the variable. Let's say that in this one it was flip-flop, so 27 plus C cubed. Then in that case, everything would be exactly the same. It would just be flip-flopped. 3 plus C times 9 minus 3C plus C squared. And that can happen. That's fine. Yeah, sometimes the variable will be on B instead of A. Okay, now, best thing ever. X squared minus 6x minus 27. These are like little number puzzles, which is why they're so awesome. So the very first thing we want to do, label A, label B, label C. So remember I said you don't have to label after this lesson. What's the next thing, Alyssa?
We still take the negative and positive?
Yes, keep whatever sign is with that particular number.
You make a big X.
Everybody give Alyssa a round of applause.
Woo!
Who can tell me what goes in the top of this X? Hold on. Flash here. So top of the X is A times C, bottom is B. Rebecca? Negative 27. Everybody give it up for Rebecca. Okay, who can tell me what goes in the bottom?
Negative 6.
Negative 6. Thank you, Alyssa. Everybody give it up for Alyssa. All right. B. So this one is A times C is on the top, B is on the bottom. Okay? So everybody think for a second. Two numbers that multiply to negative 27 that also add up to negative 6. Now keep in mind, the only way to multiply and get a negative is if you multiply a positive times a negative, okay? Keep that in mind when you're running through numbers in your head. So, you guys think of numbers? Desi? Negative 9 and 3. Everybody give it up for Desi. Okay, so negative 9 times positive 3 is negative 27. Negative 9 plus 3 is negative 6, so it fits. What's the last step? Alan? One x on both sides. Okay, and can somebody from that tell me, as long as there's no reducing that needs to happen, Cole? X minus 9 and x plus 3. Cole, where did the minus come from? That's attached to the 9. All right, everybody give it up for Cole. Yay. Shoogie. We take this initial x squared and we evenly distribute the x squared to both terms. So let's say it was x to the 8th or something. Then how many would go to each? 4. X to the 4th, x to the 4th. Perfect. All right. Questions? All right, so let's do another one. Unless I have a volunteer who would like to come up and do this one. Thane, is that a hand? Okay. Is there a hand over there, Shiggy? All right. And Aiden, you had your hand up too?
Question.
Oh, question, yes.
On the third one, will there ever be a variable on the third part?
We're going to do one that's kind of like that. Okay. The one thing I want to say about that, so the question was, is there ever going to be a variable on the third one? Remember the very first thing we said yesterday was to make sure you have factored out a greatest common factor first. And as long as you have done that and there's still a variable, make sure it's in descending order. Descending order. If it's not in descending order, you're going to have some problems. What's up, Thane?
Okay, now I'm on the
For this?
Yeah.
Okay. And you also wanted to volunteer? Okay. Go ahead and come on up, Thane. Everybody give it up for Thane! Negative 11. All right, let's get some think music going. Best handwriting you got, okay? Oh, here.
Yeah. Here we go. Yeah. Here we go. I'm thinking about bad. It's a pain in the gut. So
All right, everybody give it up for Thane! Give it up for Thane! That was good. Okay, so the only little interim step that he didn't do was take that T and put it here and here. There, there. How many people got the same thing?
yeah.
Cool. Everybody give it up for Thane one more time. Are there questions? Okay, last two problems. I know this feels long, but it's okay. We're making our way through. Whoops. All right, here we go. Now what has changed? What's changed on this? I'm going to ask for a volunteer on the last one too. So, what's changed on this problem? This is where people start to get really irritated. Let's just be honest. Throw it on out there. Crystal.
There is a 3 front of a b squared.
Cool. Everybody give it up for Crystal. It has a coefficient, which means nothing as far as how we do the problem. It just means that there's one last tiny little step. All right, so let's draw an x. Remember in the top goes a times c. What in this case is a times c? 12. Good. Now, what goes in the bottom? 8. Cool. So we are looking for two numbers that multiply to 12 that add up to 8 at the same time. Raise your hand when you can think of two numbers that multiply to 12 that also add up to 8. Fortunately, these are small numbers, so I'm not doing too many here. Okay, so raise your hand when you have an idea about two numbers that multiply to 12. I can think of a few pairs there that also add up to 8. Let's see, Deanna. 2 and 6. Everybody give it up for Deanna. All right. So the only difference at this point is when we bring down the b squared, we also bring down the 3 with it. Okay, so bring that number with it. So 3b, we still evenly distribute that b over here, and 3b over here. And then within each fraction, we want to reduce anything that can be reduced. So, can anybody see any fractions that can be reduced here? Sloan, what? What can you see? 3 and 6 reduces to what?
To 1/2. But I have a question.
Cool, what's up?
You know how it's 3b squared?
Yep.
Is that squared to 3 and to b, or just to b?
To b, just to b.
So then why are we doubling 3?
We're doubling 3 because, how do I describe it? Go ahead, Zach.
We have 2 3s and 2 b's.
Okay.
And they make
If you would prefer to look at it that way, everybody give it up for Zach. Give it up for Zach. Basically what's happening is you want to distribute the coefficient, and you see that after you reduce it, one of the 3's falls off.
Okay.
Okay?
Whatever.
Does that make sense?
I'm just going to do that.
Okay. Okay. It's just, the thing is, it's a trick that
Wait,
works.
but what if it was like, what if it was like you know how when we did 8 could be to the third, it could be taken down to 2. So say it was like 4.
This is b to the 4th?
Yeah, say it was 4b squared. So then would we take it 2b? or
No,
would we
you
still
always
do
just take the
4b?
number itself
Okay.
and then reduce later.
Okay.
Okay? Other questions? So what are our two factors in the end? Who can tell me what the final answer is? Shuggy.
3b plus 2.
Uh-huh.
And then
All right, excellent. Everybody give it up for Shuggy. Okay, last problem. Last problem. 4x plus 15x squared minus 3. A lot of us would just go on our way and say 4 times negative 3 is negative 12, and then 15 in the bottom. What's wrong with that? Why do I not just go from this the way that it's written right here? Desi? Excellent. Give it up for Desi. How about everybody give it up for Desi? Okay, so, Desi, what would it be in descending order?
15x squared.
Good.
4x, 6x.
All right, give it up for Desi again.
Yay!
Okay, so, do I have a volunteer who would like to come up and do this? You want me to give you guys a little bit of time, or do you just want to do it? Just do it. Nike. All right, just do it. So, who can tell me what goes in the top? 15 times negative 3. What is 15 times negative 3? Zach? Cool, give it up for Zach. Okay, how about the bottom? What goes in the bottom? Zach? Cool, everybody give it up for Zach. Okay, so we are looking for two numbers that multiply to 45 that also add up to 4. So two numbers that multiply to 45 that also add up to 4. So,
I guess we could do negative 5 times 9.
perfect. Everybody give it up for Sloan. Awesome. Now, what's the second to last step? Sloan.
15x over both sides.
Awesome. 15x over both sides. Everybody give it up for Sloan again. And then we want to reduce anything that can be reduced. So can either or both sides be reduced here? Yes? So somebody pick one and reduce it for me. Thane?
The 15x and the 9, divide both of those by 3.
Okay, and when we do that, we get what?
5x over 3.
Cool. Is that fully reduced? So that's that factor. How about on the left? Everybody get up, Thane. Okay, we have 15x over negative 5. Zach?
We divide 15 by negative 5.
Cool. We divide by 5, so we get 3x over negative 1. That's a 1, which is totally reduced. So who can tell me the final answer? Brandon? Cool. All right. How are we doing on questions? Everybody show me thumbs up. It was easy today. Medium, halfway, not good. Thumbs down. Show me where we are. I will give a narrative. So I'm seeing like thumbs up and halfway. That's good. Okay, cool. So you guys have an assignment here. Go ahead and write it down and then get out a textbook. And start. And everybody take us away. Factoring is awesome.